Hello to my double link list part 2. Today we're going to continue from where we stopped on the double link list. Okay, if you guys record my previous video on double link list, we went to a program where we were able to, the program was able to like print forward and backward, and that is the beauty of double link list. Double link list allows us to break out of the limitation of single link list, because single link list we are only able to print forward but we can't print backward. So that is the limitation of single link list. But in case of double link list, we are able to print forward and also print backward. So the aim of this particular video, which is the part 2 on double link list, is that regarding to the previous video, we were creating different memory dynamic memory allocation, and which is not a good thing. It's never a good practice. But in this video, what we're going to do is that we're going to create a function that we're going to use just one malloc C function to dynamically create memory and assign them to different structures. So the function is going to be returning the type of struct. All right, so that's basically what we are going to be doing. All right, so without further wasting of time, let's dive straight into the video. So I will change to the normal directory I've been using, which is double link list. Press enter, ls. You can see we have the double link list 1 and double link list 1.c. Okay, so I will just run the program real quick, just a quick reminder of what the program is doing. So if I press enter, you can see, oh, so that was not the right program. Yeah, that was the right program. So what is it saying? Being is a double link is a directory. Okay, double link links 1. So problem, just recompile that code again. Double link list.c. okay, that gives us a.out file. So that was my mistake. That will give us a.out file. So I'll just remove that a.out file and recompile again. So this time I'm giving it double link list 1. Okay, so that compiles now. So let's rerun the program. // double link list, press enter. So the program now runs. Alright, as you guys can see, this is how the program is. So let me just show you guys real quick. So I'll just move up. Okay, you can see here printing forward, which is whatever that is stored in the node data element. So we have 100 was first saved in the node element, and 200, 300, 400, 500. So we're able to save inside the struct of node element called data the value right from 100 to 500. Then we start from 500 and start printing backward. You can see the printing backward, then 500, 400, 300, 200. So this is how real applications are built. Just imagine in a case whereby we have an application that does multiple things. Okay, and this is how we're able to like link forth and back and forth in the program and execute different binary codes. Okay, so this is a very nice stuff. So what we're going to do now is just to like, I'm going to teach you guys how to make your program more clean, write a more cleaner code. All right, so I'll press the escape key to jump out of that editing mode in the terminal. So I clear the screen. ls, we have double link list 1, the executable binary, and double link list 1.c, the actual source code. So I'm going to duplicate that source code, okay, because we're going to continue from where we stopped. So I'm duplicating double link list 1.c to become double link list. I remove the 1 and 2.c. So I press my enter key, ls, and that file has been duplicated. Now you can see double link list 2.c. So I will use the Vim editor, which is my best editor so far. If I'm coding in C, I use Vim. If I'm coding in Python, I use Vim. I also do a Python tutorial very soon, so make sure you you follow me. If you're not following me on TikTok, if you're watching from my YouTube, make sure you also give me make sure you hit that like button and subscribe to my YouTube channel. All right, so single link list.c 2.c, I press enter. Yeah, so that code's open. So this is the code. I think it's about 95 lines of code. So what I'm going to do is that I'm going to rewrite the program. This print forward function is going to be a function. This print forward code here, which is how many lines of code, about 6 lines of code, is going to be a function. Why this also printing backward is also going to be a function. Alright, so I will start from both of them first. So what I'm going to do, I'm going to copy those lines first. So here my cursor is 1 2 3 4 5 then 6. All right. Okay, then let's leave this code first. Let's just work with the malloc. So these are where we added values to each of the struct node. So then these are where we did the memory allocation. You can see 5th node, 4th node, 3rd node, you can see 2nd node and 1st node. So we are going to delete all this node, all this 1st node down to the 5th node. So from here I'm going to start my delete. So to delete, I will hold Ctrl and U, and that will just keep wiping off all that. So we're almost there. This is the last one, and that is it. So you can see now the code is a little bit small now, which is just 66 line of code, but formerly it was 95 line of source code. So what I'm going to do next is that just going to take off this space here. Okay, so I'm going to write a function now, prototype. So below here will be a function prototype. So I will give a comment here, say create underscore node function prototype. This is what we call prototype. Okay, prototype is a declaration of function. So this function here is going to return a struct. All right, that was a spell word. We're going to return a struct of node, which is to this node. So and that struct of node is going to be a pointer. So the name of the function is going to be called create underscore node, and I won't be accepting an argument for now. So that is just it. So now I have to go and do the declaration at the bottom. Yes, so I'm also going to give a comment. I'm going to say create underscore node function definition. All right, and I start creating that. So struct node, which is a pointer, create underscore node, which is the identifier. So here we have no argument, and open curly brace. So here I'll be returning new node. So new node here will be a structure which I will be returning. So I have to create that. So here I will say struct node, okay, pointer, I'm calling it new node. Alright, so I'll say this is equals to null. So that should be a semicolon, not colon. So now I'll say new node. This time around I'm saying is equals to, so I'm casting to a struct because that's it. That's what I want the malloc to return. Okay, and that should be of type node and pointer. So I'll now call the malloc function and give the appropriate size of this malloc dynamic memory I want to allocate, which is will be struct, which should be struct node, and that is it. So after that I would love to check for errors, so I'll do new node if it's equals to null, and which will be false because it's not equals to null. Then what I'll be doing next here is I'll be using the fprintf to get the error printed to the screen, but I know everything works fine, so there is no error in the code. But if there is error, we would like to see what error and the error number and the error strings. Error string means what is the description of that error. Okay, so here I'll say %x \n double quotes. I'll put the error number and use the function error string and pass in the error number, and that is it. So when I'm done with that, I would like to exit. Since there was error, I would like to exit. So give control back to the main and the program will exit. So I'll be passing in arguments here called exit failure, then that is it. But if everything works fine, this part will be skipped. All right, this part will be skipped. Okay, so then that is it for now. Then what we're gonna do now is that let's allow the node to accept a function. All right, so let's allow the node to accept data. Okay, the data stored in it. Okay, so we're going to say here, so we have the new node should point to data. So I will say the data should be equals to data. All right, so new node pointing to it forward first. Okay, forward should be equals to null semicolon, and new node forward to should be equals to backward, and backward should be also be equals to null, because they are not pointing anywhere. So what I'm going to do here is I can say at here first we are giving data here. All right, so we are passing data here. Okay, let me just say here should be 0 for now. Okay, so when this returns, this will just return the structure of node that nothing was assigned to any of these place value of the node. All right, so what I will do next is that I will come to my main function, and I will come here to say instead of giving all this null, I will say let the first here be equals to, okay, let it be equals to the create, okay, underscore node, open and close bracket, and this also will be equals to create underscore node, open and close bracket. All right, and this also will be equals to create underscore node, open and close bracket, and this also equals to create underscore node, open and close bracket. So the node was not well spelled, so I'll take that off. And lastly, the fifth node also create underscore node, open and close bracket. So we just did that. All right, so at the first node now we are not saying go to that first node and we initialize the value there to be 100, then let the forward now be pointing to the second and the backward node. So all these things will just apply as usual. All right, so the prints will now print those node forwarding and backwarding. So if everything works fine, we should have our program well set and running with no errors. So let's go compile this program. So we compile with GCC, then it's called double, okay, that was not uppercase, double 2.c minus o should also be called double 2, okay, and we press enter. So it compiles ls. So we have double linked list 2, so it's time to run it. So double linked list 2, and we press enter. Oh, that was not giving the right name, there should be 2. Okay, and the program is running very well. Now you guys can see. So control B, I go up, you can see printing forward data here. We have 100, we have 200, 200, 400, 500, and you can see printing backward, we have 500, 400, 200, 200, 100. Okay, so this is pretty nice. You see, we're able to eliminate all those different creation of malloc, first malloc, second malloc. We just create only one function and apply them to other structure of node. Isn't that awesome? So guys, if you like this, okay, make sure you give me a follow, and if you are watching from my YouTube channel, please make sure you subscribe and hit the like button. Share these videos, guys. Have a nice day. Be blessed. Okay. Okay, bye bye.